So yesterday, we started chemical reactions. We went over the signs of a chemical reaction, and we talked about how in a chemical reaction, your reactants, that's the things you start with, and your products are going to be chemically different. They'll be made of the same elements, obviously, but they'll be rearranged, separated, or joined in a new way, okay, that makes their chemical and physical properties different. And that's what leads to the signs of a chemical reaction, things like temperature change, color change, okay, precipitates being formed, all of that stuff that we talked about yesterday. Then we went on to the 5 reaction types. Okay, so we just want to quickly review the 5 reaction types. If I gave you a reaction that looked like this, let's say, what kind of reaction would that be? You can refer back to your notes, I'm okay with that. This is the second day we've done it. This is a synthesis reaction. 2 elements are combining to form a single compound in this reaction. Okay, so that's a synthesis reaction. Is this reaction balanced?
Yeah.
It is, yeah. There's 1 calcium on each side, there's 2 bromines on each side. That one worked out pretty easy. Okay, what about this one? Reaction type would that be from yesterday? Single replacement, yeah, single replacement, yeah. Okay, sorry, did I hear you wrong? Anyway, okay, single replacement, okay, because we have an element and it's reacting with an ionic compound and that's making a different element, so it's replaced the part of the ionic compound that it is like. If that was a non-metal, it would have replaced oxygen instead. All right, so in this case, sodium is a metal, so it swaps out for copper, which is the metal in that compound. That's why copper ends up alone, and sodium is now part of that compound. Is that reaction balanced? It's not. Okay, what should I start with to balance it? The biggest number, okay? Biggest number is 2, and it's on sodium. On this side, there are 2 sodiums. How many are there over here? Just 1, right? Because there's no number here, right? So what do I need to put in front of this?
2.
Right. Why can't I do this? That would mean 2 sodiums, wouldn't it? Why is that different than this? This little 2 means that the sodiums are bonded together in a molecule, are they? It's not one of the special elements, right? So I would have to put a big 2, okay? I put big 2s if I want to apply it to everything. All right, is it balanced now? Yeah. Okay, 2 sodiums on each side, 1 copper, 1 copper, 1 oxygen, 1 oxygen, looks good now. Okay, so for all the reaction types except combustion, that's how we balance. Start with the biggest number. Okay, speaking of combustion, let's look at one of those. Okay, so that's a combustion reaction. We can identify combustion reactions because we know that they have a hydrocarbon reacting with oxygen and that they always produce these 2 things. Okay, no matter what the hydrocarbon is, the products will always be carbon dioxide and water. Are there special rules for these? Okay, what order do I balance in? Okay, alphabetical order. Does this require the rule of 2? It does. Okay, so the rule of 2, in case you forget from yesterday, says that if I have an even number of carbon atoms, which I do, then I have to start my balancing with a 2. Okay, as long as that's an even number, 4, 6, 8, 22, okay, doesn't matter if it's an even number, I start with a 2. All right, now I'll balance in alphabetical order. How many carbons do I have here? 4. 2 times 2 is 4. All right, so I'll put a 4 here. All right, next in line alphabetically is hydrogen. How many hydrogens do I have? 12. 2 times 6 is 12. So what needs to go here? A 6, right? 6 times 2 is 12, yeah. Okay, and now I can balance my oxygens. How many oxygens right here? 8. And how many here? 6, yeah, because there's a 1 here, right? It's an imaginary 1. We don't write 1s, but 6 times 1 is 6. What's 8 plus 6? 14. Okay, what times 2 will give me 14? 7. Okay, those are usually the trickiest ones to balance just because you got to do a little more figuring with those. Okay, and they have different rules. Okay, what would this one be?
Simple decomposition.
That is a simple decomposition reaction. We have one reactant, and all it did was break down into its 2 parts. Okay, that is a simple decomposition reaction. Is it balanced?
No.
No. Okay, now, biggest number is 2, but it's on both elements. Which one should I do first? Okay, we would think lithium because it's first, right? Like we should start with that. But here's what actually happens. If I start with lithium, what can happen, I don't know if it'll happen in this one, is because lithium has a smaller charge, okay, because lithium's a +1, oxygen's a -2, it has less of an effect on what happens in the reaction. So it's, if you have a tie, okay, if you're looking at the biggest number and there's a tie, start with the one that has a bigger charge. So if you've got a +1 and a -3, start with the -3, okay? Because it'll have a bigger effect on the numbers, okay? All right, so in this case here, okay, and here's why I'm saying that. If I just go, oh, there's 2 lithiums, and I put a 2 here, am I gonna have to erase that too? I am, because there's only 1 oxygen over here, and there's 2 over here. I gotta go back over here and put what in front of this? A 2. Now my oxygens are balanced, but this number is wrong. If I'd have just started with my oxygens, I wouldn't have had to go back and change something. Okay? So if you have a tie, and in the end, if you don't do that, you're just going to have to do what I did and go, oh shoot, I'll have to erase the number I wrote. Okay? And then change it over. All right, so now I've got my oxygens balanced. There are 2 here, and there are 2 here. But now how many lithium do I have? 4. So now what do I put here? 4. And I'm done. Okay. Sometimes that happens, okay? You get going on your balancing and then suddenly you're like, oh shoot, that's not gonna work, and you just have to erase it and start with a different one. It happens sometimes. Okay, what have we got up there? 4 different ones. Which one? Oh, I'm missing, okay. So the one I'm missing is okay, last one. That's a double replacement reaction. It's got 2 ionic compounds, okay? All that happens in a double replacement reaction is the metals switch partners, okay? Nickel was with chlorine in the reactants, nickel was with sulfur in the products, okay? Potassium was with sulfur in the reactants, potassium ends up with chlorine in the products, okay? We just switched the metals, and we've got our new compounds. All right. Is that one balanced? Okay. Do I have a tie again? Okay. This is a -1, that's a +1. There's no difference in charge. Can I flip a coin on this one? Like, does it make any difference which one I balance first? Not on this one, it doesn't. Okay, so I'm just gonna start here because this is where it starts. There's a 2 there, now I'm gonna put a 2 there. When I do that, does that give me 2 potassium? Are there 2 over here? Are we done? I think we are. Okay, let's try it again. 1 nickel, 1 nickel. 2 chlorines, 2 chlorines. 2 potassiums, 2 potassiums, 1 sulfur, 1 sulfur. Yep, we're done. Okay, ringing a bell? Guys, we're gonna spend lots of time on this, okay? So if you're not getting it right now, don't worry, we're gonna have lots of time to practice. You're gonna have lots of opportunities to ask questions. I'll come around and help, okay? But this is something we spend a lot of time. All right, yesterday we left off, and I think we had gotten to the combustion reaction there. So here's what I want you guys to do. Do these last 4, okay? I want the type. Okay, I'd like them balanced. And I'd like them written in words. So basically just write the names of all the things. Okay, I'll give you a few minutes and then we'll do the first one. I'll give you a few more minutes. You can do as many as you can, okay? But we'll go through them together one at a time. Okay, let's look at the first one here, guys. What kind of reaction is that first one?
Simple decomposition.
That's a simple decomposition reaction. That's the only reaction type that has only one reactant, right? If you don't have anything to react with, all you can do is break down, okay? And so that's what happens in a decomposition reaction. So that would be a decomp reaction, or simple decomp, whichever you want to say, okay? And then we need to balance this thing. What's my biggest number? 8. I should probably start with that one, I would think, okay? That's a giant number. So I got 8 sulfur on this side, but on this side I only have 2. What am I going to have to multiply that by?
4.
Okay, so I'm going to put a 4 in front of this. When I do that, it gives me how many nitrogen? 12. All right, so what needs to go in front of this?
6.
A 6. All right, it's balanced. 4, 6, 1. Okay? You don't have to write the ones unless it's fill in the blank. Then you'd have to write a 1, so I know you didn't leave it blank and not know how to do it. Okay? All right, now I've got to write it out in words. Is this ionic or molecular? It's molecular, right? They're both non-metals, so this would need to be written as trinitrogen disulfide. Okay, and that breaks down into, what would I call this stuff? Just this? Is this how nitrogen appears as an element? Yeah, it's one of the special ones, right? So this is just, it's just nitrogen. Okay? That's how nitrogen appears when it's an element. It's one of the special molecular elements. So that's just nitrogen. And this is also, same rule. Sulfur is the most special of the special elements. That's how it appears when it's by itself. S8, that's just sulfur. Okay? We don't put prefixes on elements when they're by themselves. Okay? Making sense? We use prefixes in molecular compounds and molecular compounds only. Okay, how many people are done the second one? Okay, let's have a look at the second one and then I'll give you a little bit more time. Okay, what kind of reaction are we looking at there in the second one? It's a single replacement, yeah. Okay, we've got an element reacting with an ionic compound, and that's going to produce a different element and a different ionic compound. So yes, definitely a single replacement reaction. Okay, is it balanced? No. Biggest number is 2, and it's a flip of the coin here. It doesn't matter which one I start with. Chlorine and iodine both have a charge of -1, so there's no choice here. I can just go. Okay, so there's 2 chlorines here. How many over here?
1.
Just 1, so what needs to go in front of this?
2.
Okay, does that give me 2 sodium? All right, gotta go back over here. What goes here?
2.
Okay, does that give me 2 iodine?
Yep.
There are already 2 iodine over here. We're good then. Okay, that one's balanced. Okay, if I'm writing that one out in words, okay, same rule as this one up here. This is how chlorine appears as an element. So that's just chlorine plus this ionic compound, which would be sodium iodide. Okay, this is just iodine. And this is sodium chloride. Guys, make sure that you always write the technical name for compounds, even if they have a common name. All right, so sodium chloride, don't write salt. Okay, salt is a general term meaning any crystalline solid. So salt is not good enough for that. Water is the one you can use the common name for. You see H2O, you can write water. Right? You don't have to go dihydrogen monoxide or hydrogen hydroxide or any of the other names that water has, just call it water. Okay? Everything else, even if you know what the common name is, okay, you write the technical. All right, I'm going to give you guys a few more minutes on the last two there, and we'll see how we do. So for the third one, I've got an ionic compound reacting with another ionic compound, producing two different ionic compounds. What reaction is that? That's a double replacement reaction. Okay, it's not balanced right now. Biggest number is
3.
biggest number is 2. Here's why. This is exactly why I put this one on here. This is a polyatomic ion. How many of CO3 are there? 1 on each side. Remember, we're not balancing that oxygen separately. We're balancing that as a unit. There's only 1 carbonate. And again, this is why a lot of people like to put brackets always around their polyatomic ions. When it comes to balancing, they find that easier to deal with. So totally up to you. If you want to do that and it makes it easier for you, go right ahead. Okay? All right, so the biggest number is 2. It's on chlorine and it's on sodium. And if I'm looking ahead, they end up together. So that's going to make my life easy. If there's 2 of them on this side, what number needs to go here? A 2. Does that finish everything off? It does. Okay, there's 1 calcium, 2 chlorines, 2 chlorines, 2 sodiums, 2 sodiums, 1 carbonate, 1 carbonate. It's balanced now. All I have to do is put in 1 number. That happens sometimes. Okay, questions on that one? All right, what kind is the last one? No, I don't see any carbon dioxide or water. I see water, but I don't see any carbon dioxide there. It's a double replacement reaction. These are all ionic compounds, right? This is an ionic compound, that's an ionic compound, that's an ionic, so is that. Okay, so double replacement. Oh, sorry, I forgot to write this one out in words. So, sorry, this is calcium chloride, okay, plus sodium carbonate. Okay, is going to give us calcium carbonate and sodium chloride. Okay, looking at the last reaction again here. If there are no little numbers, no subscript numbers, everything is a 1. Right? There's 1 hydrogen, 1 chlorine, 1 potassium, 1 hydroxide. There aren't any little numbers. Is this reaction already balanced? Mm-hmm. Yeah, it's all 1. Okay? If you don't see any little numbers, it's already balanced. Okay, that's the easiest kind to get, is if there's no little numbers. All right, if we're writing this out in words, this stuff is hydrogen chloride. This stuff is potassium hydroxide. Okay. This stuff here water. Probably haven't seen it written that way before. Okay, but how many H's are there here? How many O's? Isn't that H2O? Okay. There's 2 ways to write water because water's weird. Okay? It can behave like a molecular compound when it's written as H2O. It can behave as an ionic compound when it's written HOH. Okay? Incidentally, this is why water is neutral. When we talked about properties of compounds, we said all ionic compounds that contain hydrogen acting as the metal are acids. All ionic compounds containing hydroxide acting as the nonmetal are bases. Water has both, so they cancel each other out. And it ends up being neutral. Okay? Everybody with me there? Okay. All right, and then the last one here is potassium hydroxide. Okay, Making some sense? It's just gonna take practice. This is the big thing, guys, with Science 10 is you take all of the different sciences, but the way you prepare and study for them is very different. Okay? For chemistry, you do a lot of practice because chemistry is very skill-based. Being able to write reactions, balance reactions, okay? Identify what type of reactions, those are skills. So being able to identify those things and do those skills simply requires practice. With biology, it's a lot of reading and memorizing.
Why is it potassium hydroxide potassium?
Oh, it should be potassium chloride. Good eye. I got going on a tangent there in my mind. I like it. You guys are on the ball and you speak up. My grade 3 class, they'd just leave that. They'd say nothing. They'd just let me look stupid on my recording on YouTube. Okay. All right. So yeah, when we're preparing for biology, biology's a lot of reading and applying. Okay, it's very different studying than it is for chemistry. Physics is a lot of practice, okay, skills, math, okay, things like that. So you prepare for them all differently. So if you're looking for a way to do well in chemistry, it is to do as much practice as possible. That's why if you look in the workbook for chemistry, there's a lot there. We'll never get to all of that in class. It's there for you to practice with. On that note, if you're practicing at home, I have included the keys to all of the worksheets in the workbook in Google Classroom, so you can check as you go. Yes, it's me. Oh, you saw my password, it's all dots. All right, so in here, okay, it's in the class work tab, and if you go to other items here, okay, in there you will see the key for all the naming worksheets. Okay, the reaction worksheets with keys. So if you go into there, all the reaction worksheets that are in the workbook, those are the answers. You can check yours as you're going. Okay, and when we get to the mole equation, there's keys for that as well. All right, so you can always go to there if you're at home working on it and you want to know if you did it right. Okay. Okay. Let's do the same thing with these 5. I would like type, balanced, and written in words. Okay. Okay, let's look at the first couple here, guys. Just walking around. Looks like everybody's done the first 2 here. So, first one. Did we already do that one? I wrote that one on the board earlier this morning, totally forgot that I had it on later. Okay, so this is what kind of reaction? Synthesis, yeah. 2 elements are combining to form a single compound. That's a synthesis reaction. Okay, we're looking at sodium plus chlorine, okay, giving us sodium chloride. Right, is it balanced? Don't think so. There's 2 chlorines in the reactants. There's only 1 in the products. All right, so what needs to go here?
2.
A 2, yeah. Right, and if I put that 2 there, does it also apply to the sodium? Okay, so what needs to go here? 2, yeah. So we'd have like 2, 1, 2, okay, for those. Questions on the first one? All right, what kind of reaction is the second one? That's a combustion reaction. This combustion reaction is what makes your car go if you have an internal combustion engine in your car. Okay, so unless you're driving a cyber dumpster, truck, or a Tesla of some kind, okay, you would have this in your gas tank. This is octane. It is the active ingredient in gasoline. Okay, if you've ever gone up to the pump, okay, the different grades of gas have different amounts of octane in them. Premium has 91, okay, mid-grade is 89, and regular is 87 octane. Okay, so it's a combustion reaction, so we'll write that. Okay, do we have special rules for combustion reactions? Okay, do I need both? I do. 8's an even number. All right, so I've got to start this with the rule of 2 by putting a 2 here. Otherwise, I'm going to get a fraction when I come back to try to balance the oxygens. All right, how many carbon do I have? 16. 2 times 8 is 16. So I'm going to need to put a 16 here. We're going to get some big numbers. All right. 2 times 18 is 36, I believe. Okay. So what needs to go here? 18. Here's the good news, guys. This is a pattern you'll see happen basically every time. Okay. Whatever that number is, because I'm multiplying it by 2, that's the number that'll go here. Because I'm multiplying it by 2. Okay, so it'll be the same. Okay, 18 there. All right, now I've got to look at my oxygens. 16 times 2 is 32 oxygens there. Plus 18 times 1, so plus another 18. That should give me 50 even. All right, what times 2 will give me 50? 25. Okay, trickier balance, bigger numbers. Okay. And then, if I'm naming this stuff, octane, I'm never going to give you one you can't use the naming rules for on a quiz. I don't know what the prefix is for 18. Okay, so we could say octacarbon, blah, 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 hydride, because I don't know what the prefix for 18 is either. Okay, on a test, I wouldn't go higher than 10, okay, because then we know the prefix is up to 10. Okay, so we'll just call this octane. That's its technical organic name. Okay, plus oxygen. Okay, is going to give us, what's this stuff? Carbon dioxide. And water. Okay, I will give you guys a few more minutes to work on 3, 4, and 5 there. Okay, in case you're going like super fast, I'll put some other ones up in a little bit here. we look at those now? How many people have done all 5? Okay, how many people have done number 3? All right, let's have a look at number 3. All right. Oh, I was recording that whole time. Hope you guys didn't say anything you shouldn't have. Okay, so we got, what kind of reaction there for number 3? Got a single element, in this case a metal, reacting with an ionic compound. Single replacement, right? And that metal swaps out for the metal that's in that compound. That's why lithium ends up alone and calcium ends up with a new partner. All right, so we've got a single replacement reaction. Okay, if we're writing that out in words, calcium plus lithium nitride. Okay, gives us calcium nitride plus lithium. Okay, is it balanced? No, it's nowhere close to balanced, in fact. And my biggest number is 3, and there's a tie. So which one should I do first, lithium or calcium? Which one has the bigger charge? Calcium has the bigger charge. Okay, sometimes it doesn't matter. Sometimes you just luck out and you do it and it works. Okay, but sometimes it doesn't. So I just always go with the biggest charge. That's calcium. Okay, there's 3 calciums there, so I'm going to put a 3 here. Okay, there are 2 nitrogens here, so what needs to go here? Okay, how many lithium does that give me? 6. So this wouldn't have worked out if I'd have started with lithium then, because I'd have written a 3 over there, and then I'd have had to start over. Okay. All right. How many have done 4? Okay, let's look at 4. What kind of reaction are we looking at there? Decomposition, absolutely. Okay, we got a single reactant, and we have its 2 elements on the product side. So yes, that is a decomp reaction. Okay, we are looking at, I'm going to run out of room here. So this is going to be dinitrogen trifluoride molecular compound, so I'll use the prefixes, and that is going to break down into nitrogen and fluorine. Right? Remember, those are both special elements, so when they appear like that, when they're by themselves, we simply name them by their element name. Okay, it is not quite balanced. Biggest number is 3. Okay, I got 3 fluorine in the reactants, but I only have 2 in the products. What's the lowest common multiple of 3 and 2? 6. Okay, so what do I need to multiply this by to get 6? 2. Okay, and this? 3. All right, when I put this 2 here, though, how many nitrogen did that give me? 4. So what needs to go here? 2. A 2. 2 times 2 is 4. All right, every once in a while, you will have to ask yourself that question. Okay, you'll have to look at a thing, go, what's the lowest common multiple of these 2 numbers, and put it on each side. Okay, all right, we'll give you a few more minutes for number 5 here, and then we'll go over that. Okay, guys, can we get everybody back to their desks? Let's get started on these. Same thing. I want them in words. I want them typed. I want them balanced, please. Okay, and just so you know, none of these are on your worksheets. Okay, these are in addition to your worksheets. We're just getting extra practice here. Now is the time to ask questions. Okay, if there's something giving you trouble on these, raise your hand, come up and see me. Okay, we get it sorted out on the first day, rather than practicing bad habits and then having to break them later. Okay, so don't be afraid to ask for help. This goes beyond the prefixes that we know. Okay, this stuff can just be called hexane. All right, are we ready to go over number 1, number 2? Okay. All right, what kind of reaction is number 1? Simple decomposition, yeah, okay, it's breaking down, right? So decomp. Okay, if we're writing this out in words, okay, well, let's balance it first. Biggest number is 3, and it's on nitrogen. Nitrogen over here is a 2. What's the lowest common multiple of 3 and 2? 6. Okay, so what do I need to multiply this one by to get 6? 2. All right, and this one? Okay, so those are balanced now. There's 6 nitrogens on both sides. When I put this 2 here, though, it gave me how many oxygen? 4. Okay, so what needs to go here? 2. All right, now it's balanced. Now, I had a good question come up here, okay? And the question was, does the fact that I put a 2 here mean I have to say that there are 6 nitrogens? And the answer is no. Those big numbers don't affect your naming. They affect your balancing, that's why we put them there. But the fact that I have 2 molecules of that doesn't change what it is. It doesn't change its name, it just changes how much of it there is. Okay, so this stuff is still going to be trinitrogen dioxide. Okay, this 3, same thing. Doesn't change the name of this stuff. This is still just nitrogen. Okay, and again, there's always a temptation here to put a prefix on that. You only use prefixes in a compound. Is this a compound? This is just an element. Okay, elements don't get their names changed. Okay, this is just nitrogen. Okay, and this is just oxygen.
But isn't the oxygen on the first one just oxygen, or is it still that oxygen?
Over here?
Yeah.
No, it's part of the compound.
Oh, okay.
Right, it's N3O2, so it's combined into a compound. All right, number 2, what kind of reaction are we looking at there? Single replacement. Yeah, we got an element, in this case a metal, reacting with an ionic compound, produces a different metal and a different ionic compound. Okay, so single replacement. And guys, the reason I keep saying that is I keep repeating the pattern for each reaction. That's what we have to know. We have to know those patterns so that we can identify them. All right, so this one here, if we are balancing, the biggest number is 3, and it's on chlorine. Over there, chlorine is a 2. Lowest common multiple is again 6. Okay, so what do I multiply this by? Right. Okay, and what do I multiply this by? Okay. When I put those numbers in, they also affect the calcium and the iron. So there's 3 calcium here now, so I need to put a 3 here. When I put this 2 here, it also made 2 iron. So I've got to put a 2 there. Now it's balanced. Now for naming, Ca is just calcium. Okay. Iron. What do I need in this one? I need a Roman numeral here. All right. Chlorine is always a -1. 3 times -1 is -3. That means I got to get 3 positives out of this 1 iron, so its charge must be +3. So this is iron 3 chloride. Here's some good news. You don't have to do that twice in a reaction. If it's iron 3 in the reactants, it is iron 3 in the products. But for this one, it actually doesn't matter. When iron is by itself, does it need a Roman numeral? No. Okay, it's just iron. Okay, but if it was a double replacement reaction, that would save you work. It would still be iron 3 on the other side. And this stuff would just be calcium. Okay, all right, give you a few more minutes here and then we'll go through some more of them here. Okay, let's have a look at the last 3 here. So number 3, what kind of reaction is that? It's a combustion reaction. We have a hydrocarbon, hexane, okay? It's reacting with oxygen, it's producing carbon dioxide and water, okay? So definitely a combustion reaction, all right? Do I need both balancing rules for this one? Yes, 6 is an even number, so I need to start with a 2, right? 2 times 6 is how many? 12. So I'm going to put a 12 here, right? 2 times 14 is 28. 14 times 2 is 28. All right, my carbons are balanced, my hydrogens are balanced. Now I need to balance my oxygens. How many oxygens do I have here in the carbon dioxide? 24. Okay, and here I have another 14. Okay, that should give me 38 oxygens in the in the products. So, what times 2 gives me 38? 19. Okay, again, some big numbers for that balancing. All right, for the written in words, hexane plus oxygen gives carbon dioxide and water. Okay, questions on 3? For number 4, what kind of reaction is that? It's a synthesis reaction. 2 elements are going together. Now, notice what they did here, okay? Why didn't they write this compound here in this order? Why did they put the lithium first? Because it's a metal, right? In an ionic compound, does the metal always come first? That's why they did it. Is that something I'd put on a quiz? Absolutely. Okay, so if I'm looking at this, we've said it's a synthesis reaction. If we're balancing it, biggest number is 2. I need a 2 over here. Okay, that gives me 2 lithiums, a 2 there. Now the reaction should be balanced. Okay, and this is simply chlorine plus lithium gives us lithium chloride. Okay, questions on that one? Okay, now this one here is a little bit trickier. What kind of reaction is it? I hear people whispering, yeah, double replacement. It's 2 ionic compounds, okay? So DR. All right, if I'm balancing that, biggest number is 3. Okay, there's a 3 on nitrate and there's a 3 on fluorine, but they both have the same charge. They're both -1, so it doesn't matter which one I start with. Okay, I've got 3 nitrates here, but I only have 2 on this side. How do I balance that? 6, right? So I'm going to put a 2 here because 2 times 3 is 6, and I'm going to put a 3 here because 3 times 2 is 6. So now I've got 6 nitrates on both sides. These numbers also affect the other part of that compound. So how many cobalt do I have now? 2. What do I need to put in front of this? A 2. All right, when I do that, it gives me how many fluorine? Okay, I gotta back up over here. What do I need to put here? Okay, does that balance my magnesiums? Okay, reaction's balanced then. All right, writing this out in words, we've got magnesium fluoride plus cobalt. Actually, this is cobalt 3 nitrates. Okay, how did I know it was the cobalt 3? What's the charge on nitrate? -1. How many nitrates are there? 3. So there's 3 negative charges here. So I've got to get 3 negative charges out of 1 cobalt, cobalt 3 nitrate. Okay, on this side here, we've got magnesium nitrate and cobalt, still Roman numeral 3. That's what I was saying before. That Roman numeral won't change. Fluoride. Okay, good work today, guys. Tomorrow, we're going to start doing something like this, where I give it to you in words, and you've got to put it in formula form. Okay, so backwards is what we did today. Reminders, your lab reports are coming up due, okay, tomorrow. So if you want them looked over, you got to pop in today at scheduled help or after school, okay? Those are the other 2 times I'm available today if you want me to look them over. Otherwise, they got to be submitted 8:30 a.m. on Google Classroom. Okay, make sure it is submitted by then, please.